So the last thing we need to look at is what to do with u substitution when you've got a definite integral. Okay, so there's limits on here. It does turn out that once you do the u substitution, you never need to go back to x when you're working with these definite integrals. You do, however, need to change the limits. So the biggest thing that people make the mistake on when they do these problems is they forget to change the limits. So 99 times out of 100, whatever the limits are that you see when you start with your integral, if you're using u sub, those are not the limits you're going to end up using when you actually do the u sub. So let's take a look at how that works. So problem number one, the plan again for u sub is we are looking for something that when we take its derivative, we find that thing, but possibly with a different coefficient. And I think number one is actually an example of something that we kind of haven't quite seen yet, but should make sense to you once we do it. Okay, so we need something that when we find its derivative, when we take its derivative, we find it there in our integral. And this should obviously end in a dx. That appears to be a typo. The whole thing in the denominator, because when you take the derivative of the whole thing in the denominator, you get 2x plus 6. Yeah, and then we factor the 2 out to get the x plus 3. So yeah, that is exactly correct on that one. So we are going to make, in this case, stick with my color coding, u is blue. U equals x squared plus 6x plus 8, which makes our du 2x plus 6, which is equal to 2 times the quantity x plus 3. But we don't have, 2 quantity x plus 3, dx. It's Monday and I'm forgetting all my dx's. All righty. So we don't have a 2x plus 3 dx. We just have an x plus 3 dx. So we need to divide by 2. So 1/2 of du equals x plus 3 dx. All right. All of that should be in orange. So we'll make that in orange. Now we've got one more step to do. We have to, that didn't work. We actually have to change those limits. So now we have to find the u of 0 and the u of -1. So u of 0 equals u of -1. The u of 0 is 8, and the u of -1 is 1 minus 6 plus 8. How about 3? Yep, cool. All righty. So again, algebraically equivalent, the same thing I've been saying. All of x plus 3 dx gets wiped out with the 1/2 in the du. So our integral becomes 1/2 du, the integral, in the same order. So from 3 to 8, it is pretty common for those limits to sometimes be out of order when you're doing u sub. That's not a big deal. Crayneck. Yeah. Gotcha. Thanks. But could have been a e-hall pass, that phone call, but instead it was a phone call. All righty. So yeah, so -1 in terms of u is 3 and 8 and 0 is 8. We have du over u, right? So we've got du over u. And we are algebraically equivalent. I do have 2 du's. Look at that. So let's make it 1 over u. Cool. Now we are algebraically equivalent. Before we had 2 du's. Antiderivative for 1 over u is ln u. So we end up with 1/2 ln absolute value of u from 3 to 8 which is 1/2 ln 8 minus 1/2 ln 3, which if you remember your log rules, I can write as 1 log. Not ln 8 over ln 3, but correct idea, ln 8 over 3. Yeah. So it ends up in the argument. The way log rules work, if you have a subtraction, this whole thing is 1/2 ln of 8 over 3. As always, that last part is an issue for multiple choice. If it's not multiple choice, don't bother with it because you might do something silly like ln 8 over ln 3 instead of, ln 8 thirds. Morning. I got to remember to mark you present. Questions on any of that? All right. It's really just a remember. It's so easy to forget to do that. You've got to remember to change your limits. So same thing in number 2, we have the integral from 0 to pi over 3 of sine of x over cosine squared of x. Cosine or cosine squared? Just cosine. Cosine squared is going to be a chain rule derivative, which usually isn't what happens in U sub. And you would also then, have something way more complicated than what was left over. So my u is cosine of x, which makes my du positive or negative sine x? Negative. Derivative, cosine goes negative. They're right. Now we have to remember what we're doing because it's backwards depending on which way we're going. So yeah, the derivative of cosine is negative sine. We don't have a negative sign, so we will make it a positive sign. So we actually have a negative du is sine x dx. We need to change our limits, so we need the u of 0 and we need the u of pi over 3. Cosine of 0 is 1. Cosine of pi over 3. Nope. 1/2. No, it's 1/2. Yeah. So it's we are pi over 3. We are right here. That's a big fat marker. And we are counting 0, 1. We're counting in our y's. So we want the 1/2 right there. So square root of 3 over 2 would be down at pi over 6, not pi over 3. So I didn't fill in my signs. I only filled in my cosines there. I left those blank because the only thing I needed was the 1/2. Unit circle. 1/2. Boom. All righty. All right. So we are going to replace all of sine x dx with the negative du. And cosine squared of x is u. So we end up with the integral of negative du, and we've basically got 1 over u squared. So 1 over u squared. And that's going to go from, I did my limits in the reverse order that I would have liked. So u of 0 goes on the bottom, so that's 1 and 1/2. Do you notice how my limits are out of order? Yeah. Do you notice how I have a negative in the front? Let's simplify before we do anything else. We can just make this the integral from 1/2 to 1 of 1 over u squared du. Yep. That way it just, we can change the limits and change the sign, and it's just one less negative to worry about, one less spot to make a mistake if we think to do that. Of course, we're going to pick up a negative here because an antiderivative for 1 over u squared is negative 1 over u, correct. So we've got negative 1 over u, and we've got to evaluate that from 1/2 to 1. So we've got negative 1 over 1 minus negative 1 over 1/2, negative 1 plus 2. Yep. Which is the same as 2 minus 1, which last time I checked is 1. And there we go. Sure. Yep. Welcome. All right. All right, cool. All right, that is all the examples. Let's stop there.